Well, hello class, and welcome to our final lesson on the topic of enzymes. Hooray! I know I ended off the last video in a bit of a rush, so I just wanted to take some time to look at this question again. Right, so very often in the exams or practice, they'll ask you to use the lock and key model to explain why enzyme activity decreases at high temperatures. Right, so because the question asks you to use the lock and key model, okay, when you answer, you need to start by telling me or describing what the lock and key model is. So it's a good way to start would be saying, according to the lock and key model, right, then you can say that the enzyme acts like a lock, while the substrate acts like a key, right? And the enzyme, you remember, has an active site, right? The active site here that has a three-dimensional shape, which is complementary to the substrate, right? The substrate is able to fit into and bind to the active site. So that's your lock and key model. All right, then you can go on to explain why enzyme activity decreases at high temperatures. So at high temperatures, enzymes denature, right? They do not die, they do not melt, they denature. And what happens is that the active site of the enzyme loses its specific three-dimensional shape. Right, it is no longer complementary to the shape of the substrate. Right, the shape of the active site has changed. And therefore, the enzyme can no longer bind to and act on the substrate. And that is the reason why the rate of enzyme activity decreases at high temperatures. Now, a lot of students, right, they will just write their answer up to this point. They'll say at high temperature, enzymes denature. Okay, but that answer is not enough. You need to explain denature, so what? Right, so what? Denature, so the active site loses its specific shape. And blah blah, enzyme can no longer bind to and act on the substrate. Alright? Okay, so moving on. Now we'll be looking at how enzyme activity is affected by pH. Right, we've already looked at temperature. Now we'll be looking at pH. Right, it's still on your page 80 to 84 of your textbook. Okay, so before exploring how enzymes are affected by pH, I just want to look at an example of pH in our body. Alright, so this is the stomach. Now, do you know whether the stomach, is it acidic or alkaline? Now, if you have trouble thinking of the answer, I want you to imagine, sometimes when you burp and then some liquid accidentally comes up your mouth, how does it taste? I'm sure you agree with me that it is more acidic, right? It's a sourish kind of taste. So the stomach, at least the stomach juice, is acidic. And I need you to also recall, does more acidic mean lower or higher pH, right? So people always get confused. Right, so this is the pH scale. And if you take a look at the scale, where's the acidic side? Right? Over here on the left, most acidic. So acidic, the more acidic equals to lower pH. Alright, so you got to get the scale right. pH 1 is very acidic, pH 14 is very alkaline. So we know that the stomach juice is acidic, right? The stomach juice here, this is acidic. Now we also know that there are enzymes in the stomach, right? Enzymes that help to digest our food. So here's a question. Do you think that the stomach enzymes work better in acidic or alkaline conditions? If you're thinking what I'm thinking, then you'll think that the stomach enzymes work better in acidic conditions. But after all, the stomach enzymes are found inside the stomach juice, which is acidic. So it makes sense for them to work best in acidic conditions. And that is what we find when we look at a graph of enzyme activity against pH. So here is a graph. On the vertical axis is enzyme activity, and on the horizontal axis is pH, right? pH 6. Here's the more acidic pH on the left, okay, 0, 1, 2. And here's the more alkaline pH, or less acidic, on the right side. Now notice that for stomach enzyme, okay, just focus on this curve, dotted one for stomach enzyme. that the maximum activity happens at around pH 3, which is acidic. So stomach enzyme works best in an acidic condition. Of course, not too acidic, but around pH 3, it has a maximum activity. And we call this pH, where the enzyme has the maximum activity, we call this the optimum pH, right? Just like optimum temperature. Now, on the side note, there's another enzyme here called trypsin, which is found in your small intestine, and we'll hear more about it in our next chapter. And notice that it has a different optimum pH. It seems to work best in more alkaline conditions. Right, so different enzymes are affected by pH differently. However, whether or not you work best in acidic or alkaline pH, notice that the curve of the relationship between enzyme activity and pH is always sort of like this shape, right? It's like it goes up, then there's an optimum pH where there's a maximum activity, and then it comes down again. So most enzymes will have this sort of curve when it comes to pH against rate of reaction. Okay, take note that this looks very different from the temperature graph. Remember, the temperature graph looks something more like goes up and then it's a very steep drop. Right, so this one here for pH and enzyme activity is a bit more symmetrical, right? You see go up and then come down. Okay, so just be familiar with this shape. Now similarly, I want to ask you, how many sections could you divide this graph into? So hopefully you thought to yourself, you can divide it into two sections. Again, we use the optimum pH here as a dividing point, and we have the section on the left of the optimum pH and the section on the right of the optimum pH. Right, now that we've divided the graph into these sections, let's go on to describe the relationship between enzyme activity and pH. And for pH, it's always best to start with describing what happens at the optimum pH. Right, so in this case, at the optimum pH of pH 7, right, the rate of enzyme activity is the highest, right? You can see it. So at the optimum pH, we say that the enzyme activity is the highest. Okay, so now we can go on to describe the section on the left, and we say that as pH decreases from the optimum, so it becomes less than 7, the rate of enzyme activity also decreases. In fact, you can also comment that at pH 3, the rate of enzyme activity is 0. So this enzyme here, which has an optimum pH of 7, you should realize by now this is not the stomach enzyme, because the stomach enzyme has an optimum pH, which is much lower. Okay, so now that you've described the left side, we can go on to describe the right side. And what we say that as pH increases from the optimum, so now it's increasing more than 7, the rate of enzyme activity decreases, right? So also decreases. And about pH 11 or 12, it'll be 0. So now let's go on to explaining the relationship between enzyme activity and pH. So once again, explaining is not just telling me and describing the shape, but telling me why is it this shape? What is happening to the enzyme that causes the graph to be this particular shape? So to explain this, we usually start with the left side. So you don't usually need to talk about optimum pH, right? Unlike temperature, when we talked about optimum temperature. But for pH, we don't really need to explain what happens at the optimum. But you do have to explain why is it that when you move away from optimum, the enzyme activity decreases. And the reason is, below optimum pH, enzymes start to denature. Now again, don't stop by just using this word denature. Go on to explain what denature means. Right, that means that the active site of the enzyme loses its specific three-dimensional shape, right, and it's no longer complementary, right, no longer complementary to the substrate, and therefore the enzyme cannot bind to the substrate, and the rate of enzyme activity decreases. Well, it's the same thing on the other side. Again, above the optimum pH, enzymes start to denature. right? And then just go on to explain what denature means. So the active site, you need to know this by heart. Active site loses its 3D shape, right? It's no longer complementary to the shape of the substrate. And then finally, the enzyme can no longer bind to the substrate, right? And therefore, the rate of enzyme activity decreases. Okay, so this all needs to be at the back of your head. Right? It might sound very confusing now, but with some practice, you should be able to remember it. Yeah, so that's all really for explaining the relationship between enzyme activity and pH. Before ending off, I just want to talk a bit about some other factors that affect the rate of enzyme reaction besides your temperature, besides your pH. And two important factors are the concentration of enzyme and the concentration of substrate. Take note that this is not really in your syllabus, it's just for your awareness. I've put up two pictures here which caused a lot of controversy recently. I'm not sure if you have followed the news. But in 2009, when then American President Obama was inaugurated, you can see there are many people, right? So this is like a very high concentration of enzymes. And over here in 2017, this year, you can see that there's not many people in the latest presidential inauguration. And this is very low, right? It looks like a very small amount of enzymes and substrates together, so low concentration. So question, which one do you think there'll be a higher rate of enzyme reaction? Where do you think there'll be more effective collisions? When we talk about collisions just now, right? So clearly, where there is a greater concentration of people, or in this case, a greater concentration of enzymes and substrates, there will be a greater frequency of collisions and a greater rate of reaction. Okay, so as concentration of enzyme increases, the rate of reaction increases. As concentration of substrate increases, the rate of reaction also increases. Alright, so that's just for your awareness. Alright, we finally reached the end of our topic. So I just want you to make sure that you've really got down what you need to know for this topic. Okay, so the very important things is you need to know how to define enzymes. Alright, you need to be able to state the characteristics of enzymes. You need to also be able to describe how enzymes work, firstly in terms of what they do to activation energy. Secondly, the all-important lock and key model. Okay, and finally, you need to be able to describe and explain how enzymes are affected by temperature and pH, which is what we've gone through the last two lessons. And often they will ask you to use the lock and key model to explain it. Alright, so as long as you got all these things nailed and we'll practice it more in class, good on you. Alright, thanks and see you all in class.